Hello friends, I welcome you in lecture number 11 on normal distribution. In this lecture, we will discuss one more question on normal distribution which was asked in GTU Winter 2020 exam. First, we understand this question. The actual amount of instant coffee that a filling machine puts into 4-ounce jars may be looked upon as a random variable having a normal distribution with standard deviation equal to 0.04 ounce. Here the random variable given is amount of coffee that can be filled in a 4-ounce jar. Amount of instant coffee is considered as normal random variable. The actual amount of instant coffee that a filling machine puts into 4-ounce jars may be looked upon as a random variable having a normal distribution with this standard deviation. So here we have to consider this amount of instant coffee as a normal random variable, and it is given that standard deviation is sigma equal to 0.04 ounces. So first we write down this standard deviation for this capital X, which is a normal random variable, is sigma equal to 0.04 ounce. Next line is, if only 2% of the jars are to contain less than 4 ounces, what should be the mean fill of these jars? It is given that if only 2% of the jars are to contain less than 4 ounces of instant coffee, that means the probability that this amount of instant coffee, which is considered as random variable capital X, is less than 4 ounces is 2%. You can understand from this line, if only 2% of the jars are to contain less than 4 ounces, that is 2% of the jars are to contain less than 4 ounces amount of coffee, and that is given as 2%. That is, we are given the probability that this amount of coffee is less than 4 ounces in those jars is 2%, that is 0.02. And if this is given, what should be the mean fill of these jars? That is, what should be the mean or expected value of this amount of coffee, which we have denoted by capital X. So we are not given this mean of normal random variable, and that we have to decide using this information. Standard deviation is given and this probability is given, and we have also given that this variable capital X follows a normal distribution. So how to find out this mean fill of jars? This mu is nothing but mean of capital X, which is nothing but amount of coffee. So we have to decide this mean fill of jars, and that is nothing but average amount of coffee that we have to decide. And after deciding that average fill of jars, we have to find out that if 10,000 jars are sold, how many are expected to contain more than 4.2 ounces. So that we will discuss after finding this value of mean fill of jars. So this is easy to find out. First we start with this step. What is given? It is given that probability that amount of coffee is less than 4 ounces is 2%, that is 0.02. And if we standardize this capital X and this 4, then we have to subtract mu from x as well as 4, and we have to divide by standard deviation. We are standardizing this capital X and this 4, and we know that these two are equal, so this is equal to 0.02. We are rewriting this event x less than 4 in this form. X is less than 4, then x minus mu is less than 4 minus mu, and because standard deviation is always positive, we have x minus mu over sigma is less than 4 minus mu over sigma. So probability of this event is equal to probability of this event. Standard deviation can be 0, but here it is given as non-zero, so there is no problem if we divide by sigma. And now we know that this x minus mu over sigma is nothing but standard normal random variable denoted by capital Z, and we have to find out value of mu. Sigma is given, it is given that sigma is 0.04, so we substitute value of sigma here, and this is equal to 0.02. This means we have to decide this value of Z such that probability that capital Z is less than this value is equal to 0.02. So to find out this value, 4 minus mu over 0.04, in which mu is unknown, we can use the standard cumulative normal probability table. We know that we are having cumulative probability tables for this type of cumulative probabilities. We are having values of this type of cumulative probabilities, or areas to the left of this point Z are given in the cumulative probability table. So in that table we have to search for this value 0.02. We have to search for 0.02 area, and after searching that 0.02 value of area in the table, we will be able to decide the corresponding value of Z. We have to search in the table that for which value of this small z this probability is equal to 0.02. So that is easy to find out. Now we are moving towards cumulative standard normal table, and in that table we have to search for 0.02. So let me search here. These are the cumulative probabilities, and we are interested in 0.02 area. In this table we are having cumulative probabilities. All these table values are for this type of cumulative probability that capital Z is less than small z, or all these values are areas to the left of this point Z, which are given here in this column and in this row. These are the values of Z corresponding to all these areas, and I have to search for 0.02 value in this table. So let's try to search for 0.02 here, and here we can see we have minus this is 0.06, and I am interested in the 0.02 value. So you can see all these values are near to 0.02. This is 0.0207, 0.0202 and 0.0197. These two values are nearest to 0.02, and if we measure the distance of all these values from 0.02, all these values are near to 0.02, but we have to find out the value which is closest to 0.02. So we will select that value such that difference between 0.02 and that value is minimum. So we can see this will work here, 0.0202. This 0.0202 is the value which is closest to 0.02. So we have to write down corresponding value of z. Here I have minus 2.0, and if I consider this column, then I have 0.05. That means the value of z for which we have this area is minus 2.05. From this table we find that probability that z is less than minus 2.05 is equal to 0.0202. Therefore this is our required value, minus 2.05. so that we can substitute here. We can also write or mention here in the bracket that from table we find that probability that capital Z is less than minus 2.05 is equal to 0.0202, which is equivalent to, or which is rounded down to 2 decimal places, and it is 0.02. Therefore this value must be equal to this value. So from this we find that therefore 4 minus mu divided by 0.04 is equal to minus 2.05. and now we can solve this for mu. This I can rewrite as 4 minus mu equal to minus 2.05 times 0.04. Therefore 4 minus mu is equal to negative of product of these two, which turns out to be 0.082, and we are interested in the value of mu, so we consider mu on this side and this 0.082 on left hand side. So therefore we find that mean of amount of coffee is 4.082 ounce. So your question is, what should be the mean fill of these jars if only 2% of the jars are to contain less than 4 ounces? That is, if probability that capital X is less than 4 is 0.02, what should be the mean fill of these jars? So mean fill of jars is nothing but 4.082 ounces. Mean fill of jars is equal to 4.082 ounce. Okay, now we have to find out some another thing also. Out of 10,000 jars sold, how many jars are expected to contain more than 4.2 ounces? So they have told us that they are selling 10,000 jars, and out of 10,000 jars sold, we have to decide the expected number of jars which contain more than 4.2 ounces. So for that we will first decide the probability that amount of coffee is greater than 4.2 ounces, and then we will multiply this probability by 10,000 to obtain the expected number of jars which contain more than 4.2 ounces. So first we find out this probability that X is greater than 4.2. So let's start with that probability. We are interested in the probability that capital X is greater than 4.2 ounces. So this we can rewrite as 1 minus probability that capital X is less than or equal to 4.2 ounces. Now here X is a continuous random variable, so it does not matter whether we write less than or equal to or strictly less than, and here we are using the fact that these two events x greater than 4.2 and x less than or equal to 4.2 are mutually exclusive events. So first we decide this probability that x is less than or equal to or x is less than 4.2. So to find out this probability, I have to again standardize this random variable x. So I subtract mu and divide by standard deviation on both sides. 4.2 minus mu divided by standard deviation. This I can rewrite as probability that capital Z is less than 4.2 minus we have obtained this value of mu which is 4.082 and I have to divide by sigma which is given as 0.04. Now I have to decide this value. So if I use my scientific calculator, I find that this reciprocal turns out to be 2.95. If we calculate this, 4.2 minus 4.082 divided by 0.04, then it is 2.95. Now this probability I can decide using cumulative normal probability table. I have to search for 2.95 in the cumulative standard normal table. So now here all these values of z are negative. We are interested in 2.95. So let's move ahead and search for 2.0 on this side. We have to find out area corresponding to this value of z equal to 2.95. That we can rewrite as 2.9 plus 0.05. So I have to search for 2.9 in this left column. So 2.9 is here, and on this column headings I have to search for this 0.05. So 0.05 and this column and row corresponding to 2.9 and intersection will give us the probability that capital Z is less than 2.95. So I have to go down up to 2.9 and then I have to take intersection. So let me sketch clearly. Here I have this row corresponding to 2.9 and this column heading for 0.05 and intersecting point is point of our interest. So now we remove these two and we find that this value is 0.9984. This means probability that capital Z is less than 2.95. This is 2.9 and this corresponds to 0.05. This is nothing but 0.9984. So we are interested in this value. We substitute here 0.9984. So this is using normal probability table or simply using table. But we are interested in this probability that x is greater than this 4.2. So now probability that x is greater than 4.2 is equal to 1 minus probability that x is less than 4.2 and this is probability that capital X is less than 4.2 which we just obtained. So I subtract this from 1 and what is the difference between these two? So the difference is 0.0016. So we can say that the probability that amount of coffee is more than 4.2 ounces is equal to 0.0016. Now we are interested in the number of jars which are having more than 4.2 ounce coffee. So that we can find out by multiplying this probability by total number of jars. Total number of jars they have sold is 10,000. So out of these 10,000 jars sold, how many are expected to contain more than 4.2 ounces. So we have first obtained the expected probability that mean feel or expected probability that amount of coffee is more than 4.2 ounces. First we have to obtain this probability that amount of coffee is more than 4.2 ounces in a jar, and after calculating this probability we have to multiply this probability by total number of jars to obtain the expected number of jars which contain more than 4.2 ounces. So now we multiply this by 10,000. So now we write in this way, therefore expected number of jars who contain the amount of coffee which is more than 4.2 ounces is equal to 10,000 times probability that capital X is greater than 4.2, and that we have obtained as 0.0016 and product is 16. So this is the answer. There are 16 jars out of this 10,000 sold which contain more than 4.2 ounce coffee. So this is very nice question related to the normal distribution. You are already given that your random variable is a normal random variable, so you don't have to think that which distribution is applicable. Here it is already mentioned that this random variable amount of coffee is a random variable having a normal distribution, and you have to first understand that it is given that 2% of the jars are to contain less than 4 ounces. That is, you are given this probability that amount of coffee in a jar is less than 4 ounce is 2%, that is 0.02. So using this probability and by standardizing this random variable x, we are able to decide value of mu using statistical table, and once we decide value of mu we can find out this probability, and once we find out this probability we can decide the expected number of jars who contain more than 4.2 ounces by multiplying that probability with 10,000. So this is all about this session. I hope you like it. If you have any doubts you can ask in comment section. Thanks for watching.